So we're asked to find the values of a and b that make the following piecewise function differentiable everywhere. So how would we go about this? Well, first thing we would have to do is set these two equations to each other. So we would do a of x, ax plus b is equal to negative 3x squared plus 3x minus 2. And now we would have to plug in this because we want to make sure that these functions are actually continuous at -2, because we know that they're continuous everywhere else except -2. We want to make sure they are equal to each other on at -2. That's why there's two different functions. They're lines, so that means they are continuous functions, but we want to make sure that they're continuous at -2. Because if they're continuous at -2, they can be differentiable at -2 as well. In order for something to be differentiable, it has to first be continuous. And we make sure it's continuous by setting them equal to each other. And we have to make sure that they actually equal each other. So a -2 plus b is equal to -3 -2 squared plus 3x minus 2. Oh, not x, but -2 there. And minus 2. Okay, so we can't really do much in this side of the function, but we can actually do a lot here and algebraically break it down. So in the end, this would be positive 4. 4 times -3 is -12. Plus 3 times -2, which is 6. Which is -6. And minus 2. So we have -12 minus 6, which would give us -18 minus 2, which would give us -20. And then we know that a minus 2 plus b equals to -20. So let's write that up here, because we need to use this equation right here that we created by setting them equal to each other. Make sure that they actually equal each other. Okay. Now, we still need to find a and b, because without at least one of these, it's practically impossible to solve this. So we could erase this right here, and we have to set the derivative of each of these functions equal to each other. We have to set the derivative d over dx of ax plus b equal that the derivative of ax plus b to the derivative of -3x squared plus 3x minus 2. Okay. Now, the derivative of this equation, ax plus b, is just a. Now, a equals the derivative of this, and the derivative of this is just, we know that 2 cancels, so we can get rid of that. We know x cancels here, so, and 2 would come up here, and we would do -3 times 2, which would equal -6. So it would be -6 plus 3. -6x, because we almost forgot about this x. So I would put this x here, and then 3. That's the derivative. And now we want to put in the -2, because that's where this function is, we need to make sure is differentiable at. So a is equal to -6 times -2 plus 3. this would equal positive 12. So a equals positive 12 plus 3 plus 3, 12, 13, 14, 15. And then a to 15. So throughout this derivative thing, we found out what a is equal to. And we could use that in this equation up here to solve it for sure. Oops. Oops. So let's solve it for sure. So we have 15 negative 2 plus b equals negative 20, right? 15 times negative 2 is actually negative 30 plus b equals negative. And then we add negative 30 here, 30 to this side, we get b is equal to 10. So we know what b is equal to, and we also know what a is equal to. And these are the answers.